Okay, so the ones that are important to recognize, to be able to recognize their antiderivatives. 1 over x, we talked about this already, is the natural log of the absolute value of x or the natural log of x. The antiderivative. The antiderivative of e to the x is e to the x because when we derive e to the x, we still get e to the x. Right? So those work back and forth. The antiderivative of cosine of x is sine of x because when we derive sine of x, we get cosine of x. And the antiderivative of sine of x is equal to negative cosine of x because if we derive cosine of x, it gives us a negative sine of x and then a negative sine. Negative is a positive.
It's chapter 19.
Okay, any questions about this? These general antiderivatives. These ones in the middle, memorize them. That's your best option. What? Yeah. All right, can I go on?
No. Ma'am, stop holding up your. It's freaking me out.
What's your favorite kind of math to teach?
See, because calculus,
math.
I think calculus. I think your least favorite would be like geometry, algebra. That geometry, I don't hate to do that because it's so much to understand it almost level. I've explained it for like 10 times. I think that's
I don't know. I like a lot of different classes for different reasons. I think this stuff is really cool. But
I think it's torture.
most students think it's torture, and so it makes it really hard.
Exactly.
You what? Okay. Find all functions of g such that g prime of x is equal to 4 times sine of x minus 3x to the 5th plus 6 times the 4th root of x to the 3rd. So what is this asking us to do? Find all functions g such that g prime of x is okay? So we're finding the antiderivative because we want to know what g could have been if the derivative got us here. And so with addition and subtraction like this, we can underderive each part of it to get the antiderivative of the entire thing. And so I'm going to start with 4 times sine of x. We talked about this constant. This constant can just stay in front, and then we underderive this piece here. So starting with,
Would it be big G?
no, because they've given us the prime, and so if we undo that, then we just have g of x.
Is that what we're just finding g of x or the big G of x?
It's the same,
Oh, okay.
same thing. The capital G is used for an antiderivative.
Oh,
If they've given me the prime, then I can just write that it's this.
oh, okay. I got it.
So 4 times sine of x, how do I underderive 4 times sine of x? Let me ask that question differently. What is the antiderivative of sine of x?
Cosine.
So 4 times negative cosine of x
Negative 4.
is the antiderivative of this piece.
Can you do negative 4?
Yes, I can do that. I will do that on the next step. Okay, then I'm going to move to this part right here. So I have minus 3, and I'm going to find the antiderivative of x to the 5th. How do I find the antiderivative of x to the 5th?
Add 1 and then divide by 6 and plus 2. It's not so enthusiastic, guys.
Okay, Samuel.
6 plus.
Okay.
What?
add 1 to the exponent, and then divide by that power.
Wait. Why is 30 stay the same?
No.
It's just a constant. Constants move in front. And then I just underive the 1 part. Finding the antiderivative of x to the third. Find the antiderivative of a power. I add 1 to the power and then divide by that number.
But wouldn't there be a 6 in front of that?
What do you mean?
Because wouldn't there, if you derive x to the power of 6, wouldn't you be 6 in front?
Which is why we divide by 6. Because then those 6's will cancel out. You want me to derive this?
Yeah, can you like show me how to derive?
X to the 6th over 6. If I find the derivative of this, then I bring the 6 down and I get 6x and I subtract 1 to the 5th over 6. 6 over 6 cancels out and I'm left with x to the 5th.
What about the 3?
That's why I left the 3 here.
I was going to say the same because if you, okay, so say you're deriving that function, you have to derive it. No, it was the same because you have to derive that.
I'm going to get to the simplifying. What I'm trying to show you guys is that you bring constants to the front. Obviously, we're going to simplify this. I'm not going to leave this as 4 times negative cosine of x. I'm not going to leave this as 3 times x to the 6 over 6 because I know that this can reduce. But as I show you an initial problem, I'm going to go through every single step. Okay? Can we do that? Can we get through every single step?
Yes.
Constants move in front. That's how you do an antiderivative. There may come a point where you don't have to show that work anymore. Right? This work does not have to be shown every single time, but I'm going to show you why we get what we get. Because if I were to just write x to the 6 over 2, then you would all ask me 1,000 questions then also. This is a lose-lose situation. I would just let you know. You're making my life
A living hell.
wonderful. All right. Stop talking. Before I underive this, I'm going to write this as power. So how do I write the 4th root of x to the 3rd as a power? 3/4. Power goes on top, root goes on the bottom. So to underive this, to find the antiderivative, what do I do? Add 1.
And then put that number
Yes.
on the side. So it'd be 7 over 4.
That's pretty.
Gorgeous.
Did you say you hate it? Yeah. Okay. So, again, I want to emphasize that we're just going through the same step every time. So if I have a power, I add 1 and divide by that power. We're now going to simplify everything. All right? So, I do not write 4 times negative cosine of x. I'm going to bring that negative in front and get negative 4 cosine of x. Right here, if I'm multiplying 3 times x to the 6th over 6, then these are going to reduce to be 1/2 x to the 6th.
You just put that over 2. Or would you prefer we go?
I would prefer you write it this way. No, that's not what I'm doing. You're going to see that coefficient more often. You want me to derive this again?
Yeah. No, I'm sure that's the one.
Oh, yeah. Of course. Okay, over here, I've created this like complex fraction. If I'm dividing by a fraction, I flip and multiply, right?
Yes.
So this becomes 4/7 times 6.
21.
21?
Oh, wait, no, never mind.
Okay. Flip this and multiply. So this is now 4/7 x to the 7/4, 4/7. 4/7 times 6 is 24 over 7. Okay, I have to find all functions g. So what do I have to have? plus c. This is my antiderivative. Now, let's check. Nope, we're going to check it.
We check my deriving again?
So I'm going to check this by deriving, and we've had lots of practice with deriving, so we can do this. So I'm going to derive negative 4 cosine of x. What's the derivative of negative 4 cosine of x? What do we say? Yes, because the derivative of cosine is negative, and so those negatives cancel out. I'm going to find the derivative of 1/2 x to the 6th. So how do I derive this? I bring the 6 down. 6 times 1/2 is 3. Subtract 1. I get x to the 5th. 24 over 7 times x to the 7/4. How do I derive that?
Bring 7 over 4.
I bring-
Multiply by.
Okay, so I multiply this by 7 over 24. 7's cancel. 24 over 4 is 6. And then I subtract 1 from the power to leave me with 3/4.
Which is the C.
When I derive a constant, I get 0, so this is my derivative, which matches the function that I was given.
We wouldn't have to write plus c right there.
There is no plus c when you derive. If I derive a constant, I get 0. This is my answer. This was me checking.
Sam. What happened? Negative 6? And 6?
Okay, any questions on this example?
4.
Did you say more?
Is there anything else there?
Others.
What did you say?
For me?
Yes!
I said home.
Question sheet?
Yeah.
What's next?
Information I lost the derivative of
So in this case, this is one of these situations where we've been given an initial condition. So we're going to talk about this after we underwrite. Okay, this question is asking us to find f if f prime of x equals e to the x plus 20 times 1 plus x squared to the negative 1, and f of 0 equals negative 2. So what are we being asked to do?
Find the
The antiderivative.
with F.
So we're going to take each of these individually. We're going to start with the antiderivative of e to the x. What is the antiderivative of e to the x?
E to the X.
Okay. Now let's look at this a little differently, and you're going to go to your chart in just a minute here. This is 20 times 1 over 1 plus x squared, right? Because they're telling me that this is 1, which means it's really in the denominator of a fraction. What? Question? No, I'm finding my function, my original function, after being given my derivative. We're gonna get, yeah, we'll get to that. Question? Okay, so this is 20 times the inverse tangent of x. This should have come from your chart, where the antiderivative of this is the inverse tangent of x.
Wait, are we finding the antiderivative?
Yes.
So shouldn't that be a capital F?
No, because they've given us f prime of x, and if they're showing me the prime, then the antiderivative is not.
I asked that like 3 years ago.
It doesn't matter. If you use a capital F, that's fine.
Okay, hold up. I was writing something down, so that's why I didn't hear the part for 3 years ago. Yeah, you did. Okay, never mind. I was just watching the video.
Okay, when I am underiving, there's always this random constant at the end for a general antiderivative. This problem in particular has given us what's called an initial condition. They've told us that our function is, they've told us about a specific function. And what we know is that if we plug in 0 for all of these x's, then this function has to equal -2. And so I use that to solve for c. So I'm going to say that my function equals -2 when I plug in 0 for x. Please stop talking. So e to the power of 0 plus 20 times the inverse tangent of 0 plus c.
Oh, I see.
What is e to the power of 0?
1,
1. What about inverse tangent of 0?
0.
This happens at 0. So remember this question, we're asking ourselves, at what point does tangent equal 0? And tangent is going to equal 0 when it's 0, when we're at 0. If you think of the unit circle, when we have sine over cosine, and that would be 0 over 1. The degree or radian measure 0. So 1 plus 0 plus c is going to equal -2. So what does c equal?
Wait, what's wrong? Where did the 20 go?
20 times 0 is 0. That's the inverse tangent of 0. So now c is equal to -3. So I'm no longer dealing with this general antiderivative, but I have a very specific answer for this function. That is e to the x plus 20 times the inverse tangent of x minus 3. Because I know that that constant that somehow disappeared in my derivative is equal to -3. Based on the information they've given me. Does that make sense? So there's one of two things that you're going to be doing. You're either getting a general antiderivative, and a general antiderivative has to have the plus c at the end, or they're going to give you specific information, and you have to use that to find c, and then you have a function that's very specific. Okay. Ready? Keep going. Can we do another example?
Sure. Yay!
Double derivative.
Double derivative.
Okay, we are asked to find f, and we're given f double prime. So we are going to have to find two antiderivatives here.
Is it the homework?
Huh?
It's in the homework, isn't it?
Yes.
No, this is on the homework.
And
So we can only do this one step at a time. We have to start by finding the first derivative. The first derivative comes from underiving our second derivative. Okay, so we're undoing this. So for my second derivative, I have 12x squared. How do I underive 12x squared?
12 there?
Keep the 12 there.
One to the power and then divide by that number.
But did anyone else hear you?
No.
No.
That's why you repeat it and say it louder so that they can't repeat it.
What did you say?
Add 1 to the power and then divide by that answer. Then we have plus 6x. How do I underive 6x?
6 times x squared over 2.
So add 1 to the exponent and divide by that answer.
Oh, this is like a pattern.
What if I'm underiving 4?
You add x.
Add
There
an
had
x.
to have been an x there, right? And then what?
Plus e.
Plus c.
What's the
Okay, we are going to have to underive this twice. So I'm going to write this as c sub 1, because we're going to end up with another c. Now I'm, oh, let me simplify this. We have 12 times x to the third divided by 3, so this is 4x to the third. 6 times x squared over 2 is going to become 3x squared minus 4x plus c sub 1.
Why are you doing 4 times x?
I just simplified that. Okay, now I want to underderive this to get to my function. So in order to underderive 4x to the third, what do I do?
4 up front, add 1 to 3, and then divide by 4.
Okay, so I add 1 and divide. I'm going to do the same thing here with 3x squared, so the 3 stays in front. I add 1 to the exponent and then divide. Right here where I have 4x, that 4 is going to stay in front. I add 1 to the exponent and divide.
What do you do with the plus
So they are up front. They're here.
And you don't put plus
Okay.
c.
Is it CX because C is a number?
Okay, so in my first derivative, c is a number. So if I'm underiving a number, it's just like what happened right here with this negative 4.
and then plus
This has an x with it, so now it's c sub 1 times x.
and then c sub 2.
Sub 2.
And then we come out with a second constant here with our, by underwriting twice. Okay,
Wait,
yes.
why does? I didn't know if it's positive or negative,
What do you mean?
the plus C2.
I don't, but I don't
Because if
care at this point.
C is, when the C is negative, it would just be like subtracting.
Yeah. It'd be like having plus a negative number, and I'm gonna get rid of that plus if it is negative, once I figure it out. But I don't care unless it's information that I can find at the end.
Well, can't you find it at the end because you're given s?
Yep. That's what we're doing. So I'm gonna simplify this first, just so that everything is in its simplest form. These 4's cancel out to leave me with x to the 4th. These 3's cancel out to leave me with x to the 3rd. Negative 4 over 2 reduces to negative 2x squared. And then c sub 1 times x plus c sub 2. Okay, I want to start with the information where I can plug in 0 for x. That's the easiest one because anything multiplied by x is going to turn to 0. So when I plug in 0 here, my function is equal to 4. So 4 is equal to 0 to the 4th power, which is 0, plus 0 to the 3rd power, minus...
0
Right, can you just...
equals c sub
Then
2.
0 and c sub 2
So c sub 2
is equal to 4, because when we plug in zeros for all these x's, then we're
Except
going
that
to
3
get 4.
right there.
And how would you find c sub 1?
Okay, to find c sub 1, we use the other piece of information that we're given. We can't use the 0 because we can't cancel out c sub 1, and that will happen if we plug in 0. So I plug in 1 for x. I know that when I plug in 1 for x, my entire function should equal 1. So 1 is equal to 1 plus 1 minus 2 plus c sub 1 x. No, c sub 1 plus 4. So by plugging in 1 for all of the x's, this is what I end up with. 1 plus 1 minus 2 goes away. They cancel each other out. Subtract 4 and c sub 1 equals negative.
Why does c sub 2 equal what?
Because I already found that when I plugged in 0 for x.
Is there a certain order you should do it in?
When x equals 0.
So then c sub 1 is equal to
Negative 3. So my function, my very specific function here is x to the 4th plus x to the 3rd minus 2x squared minus 3x plus 4. And this is the function when this is the antiderivative and those two pieces pieces of information are
This is
true.
a whole process. It's like a path to like.
Yes.
Alright, what do we look at antiderivative now? Oh my goodness.
That's what it's called in it. It's a brand. It's a brand, but you like people pronounce it Spanish because it's a Spanish brand, right? It's by isn't it by laser?
That's true.
Yeah.
Hold on.
In Spanish, it's the you know the cups, the regular ones? Those are called maruchan.
I feel like you practice enough, those were very intense examples, I feel like you practice enough to understand this stuff without further delving into our own
And I like antiderivative.
What was this?
It says it on there.
Ones do like, the ones do like 35 bars.
You know the computers in the microwave, it gives off radiation. Well, something about with star radiation.
Freaking bag
I
then.
know, right? The bag tastes so good.
No, I like the bag better. It tastes better. I'm gonna do that one. No, I don't have to. I know, but she put this. She does the water and then she puts the noodles out and she puts like bring it all together. So she doesn't wait for it to cook. I wait for it to cook because.
All right, 1 through.
I'm very specific on that. You're gonna sick all
Yeah, no, it tastes so good.
1 through 41, every other odd. Okay, tomorrow we will spend time reviewing things from chapter 4. I gave you guys a list of the standards that you need to know for that test yesterday. So if you didn't get that yesterday, then ask someone in class who has it. Tomorrow we'll spend all day reviewing. You have a test on Friday, which also means your homework from chapter 4 is due on Friday. You are just a bundle of joy today.
There are a lot of us.